Okay, let's do another one. So let's show that tan squared x minus cotan squared x is secant squared x minus cosecant squared x. Now, both of these sides, it seems like I could do something with both of these sides because I could rewrite this left-hand side in terms of sines and cosines and the right-hand side in terms of sines and cosines. I'll just randomly pick the left-hand side. Maybe it'll work, maybe it won't. So tan squared x minus cotan squared x, that would be sine squared x over cosine squared x minus cosine squared x over sine squared x. So that's just using the reciprocal identities. And now I can go ahead and get a common denominator by multiplying by cosine squared x here. And right there, I'd need to multiply by sine squared x over sine squared x. And so what I'd get is, well, sine squared times sine squared, that's sine to the fourth of x, minus cosine squared x times cosine squared x, that'd be cosine to the fourth of x, all divided by, and I'd have sine squared x, cosine squared x in the denominator. All right, so this is my common denominator step. And now I look at this, and while you may not see this right away, what I see in the numerator is a difference of squares. If you have a to the fourth minus, well, first of all, let's recall that if you have a squared minus b squared, that's a minus b times a plus b. And so if you have a to the fourth minus b to the fourth, well, that is the same thing as a squared squared minus b squared squared. And so if you think of this as capital A and this as capital B, then that would be a squared minus b squared is a minus b, a plus b. And now capital A is a squared, so this is going to be a squared minus, and capital B is b squared. So this is a squared minus b squared, a squared plus b squared. So a to the fourth minus b to the fourth is a squared minus b squared times a squared plus b squared. And so sine to the fourth of x minus cosine to the fourth of x, that's going to be, I'm going to go ahead and remove this. That's going to be, well, sine squared x, what does this say? This says a to the fourth minus b to the fourth is a squared minus b squared. In this case, a is sine of x and b is cosine x. So a squared minus b squared, b is cosine, so cosine squared x times sine squared x plus cosine squared x, all divided by sine squared x cosine squared x. And you could go ahead and check this step. If you foiled this out in the numerator, you would get sine to the fourth x, that's this term here. Then you'd get minus cosine squared x sine squared x plus cosine squared x sine squared x. Those would cancel. And then finally you get minus cosine to the fourth x, which is exactly what this numerator is over here. Okay, so can I do anything with this? Well, sine squared x plus cosine squared x, that's just 1. So this is sine squared x minus cosine squared x divided by sine squared x cosine squared x. So this is the Pythagorean identity. And this here was factoring. And now what can I do at this point? Well, I could split up this fraction. I could write this as sine squared x over sine squared x cosine squared x minus cosine squared x over sine squared x cosine squared x. Let's go ahead and try that. So this would be equal to sine squared x over sine squared x cosine squared x minus cosine squared x over sine squared x cosine squared x. And now sine squared x over sine squared x, that's just going to cancel. So I get 1 over cosine squared x minus 1 over sine squared x. And now where am I trying to get to again? I'm trying to get to secant squared x minus cosecant squared x. If you ever get lost in your calculations and you don't know where to go, take a peek at the right-hand side and see if you're getting close. Well, 1 over cosine squared x, that's secant squared x, so secant squared x minus cosecant squared x. And this is the right-hand side. And I suppose that I should go ahead and say what I'm doing here. So fraction, then this is just some canceling sine squareds and cosine squareds, and then finally we have a reciprocal identities. So at this point, hopefully you're getting a sense of, what can you do when you're solving these trigonometric identities.